It's a great pleasure for my colleagues Justin Powell, Stefan Bordes, and me to welcome you all to our already fourth event of the lecture series Science of Science in the Spotlight. And yes, most of us are still working remotely, and the current pandemic has a large effect on our daily life and academic exchange. We all miss our annual conferences, smaller workshops, and also the team meetings and the coffee breaks with our colleagues. But having decided to shift the lecture series into an online format gives us the opportunity to interact with our colleagues from around the world and listen and talk to speakers we wouldn't be able to meet personally. And so I think it's time to say thank you to all of you who are here today. And I already see many familiar names and who already joined us in earlier versions of the lecture, and also your motivating feedback and encouraging words to continue the lectures, especially during these times, means a lot for us as organizers of the lecture series. Sorry. But let me now come to our speaker of today. It's Chaomei Chen, and he's a professor of information science in the College of Computing and Informatics at Drexel University in the USA. Before coming to Philadelphia, he was appointed at Brunel University, Glasgow Caledonian University, the University of Liverpool, and the Library of Chinese Academy of Sciences. In 2008, he was awarded with the Chang Jiang Scholar Award, and this is the highest academic award issued to an individual in higher education by the Ministry of Education in China. Chaomei is also visiting professor at the WISE Lab at the Dalian University of Technology in China, and together with Drexel University, they constitute the Joint Institute for the Study of Knowledge Visualization and Scientific Discovery. Chaomei holds a Bachelor of Science in Mathematics from Nankai University in China, a Master of Science in Computation from the University of Oxford, and a PhD in Computer Science from the University of Liverpool, both in the UK. He is the editor-in-chief of Information Visualization and the field chief editor of Frontiers in Research Metrics and Analytics. Further, Chaomei is an editorial board member of the Journal of Data and Information Science. He's the author of a series of books on visualizing the evolution of scientific knowledge, as well as strategies and techniques for critical thinking and discovery, including representing scientific knowledge, the role of uncertainty, the fitness of information, quantitative assessments of critical information, turning points, the nature of creativity, information visualization beyond the horizon, mapping scientific frontiers, the quest for knowledge visualization. Further, he has published many important research articles and is the creator of the widely used visual analytics software SiteSpace for visualizing and analyzing structural and temporal patterns in scientific literature. And today, Chaomei will talk about the role of uncertainties in the science of scientific knowledge. And before we start with the lecture, please make sure that your microphones are muted, and please use the chat function as always to pose a question, and I will call you during the breaks for discussion, and we will also have time for a final discussion at the end of the talk today. So Chaomei, the floor is yours.
Okay, let's share the content. Can you see the slide?
Okay. Yes, we can see everything.
Right. Thank you, Jennifer, and thank you for the organizers. And I'm very pleased to have this opportunity to share my thinking and some of the examples. And thanks for everyone for joining us. This is the topic I'm going to talk about, mainly focus on the uncertainties, how when we deal with scientific knowledge. So here I have a few background readings, if you want. Here are some of the books about the evidence, subjectivity of evidence, and uncertainty. So here, just a brief reference. So another thing I would like to mention before I get started is the journal. Jennifer mentioned we're running research topics, and hopefully everyone have interest to contribute. So this is the annotation. All right, so here's today's outline. I'm trying to cover these topics in this order, so give you a sense what I've been thinking about uncertainty, how this uncertainty can be integrated as a part of visual analytic analysis process, and also what does it mean to the general, in the general context of science of science. So at the, I guess at the end of each part, you could have some questions. I'd like to see if you have any clarification or any questions I can briefly handle just before we move on to the next section. Okay, so first of all, I'll talk about some of the scientific change theories, what are supposed to happen according to these theories. They're not all consistent, but interestingly, we select a few theories that can support from different perspectives, what's going on in science and how the scientific knowledge develops. So the second one, I'm going to focus on structural properties. Actually, there are two parts. One is the structure of scientific knowledge at the highest level from the human being or scientific community collectively. What are the structures? What are the major properties? And after that, the third part will be a brief introduction of structural variation analysis. This is kind of the principles behind lots of our work. Where can we find the most important information? Where, which area we should pay more attention? So those are the foundations of the following topics. So, and then the next one will be focusing on the dynamics of attention space. So how things are moving from one part to another, what are the triggers, and then that will lead to the discussion about is the uncertainty or the concept of uncertainty. What are the roles this uncertainty concept can play when we study how scientific knowledge is created, is transmitted, or is communicated, or is decayed or forgotten, and many other those kind of situations. So the next one is a semantic predication, and that's an interesting role play in how we measure the uncertainties, how we calculate an uncertainty at multiple levels at the, for example, at the sentence level, and also go up at the article level, and also we can go even further up at the clusters of articles, and could be going even higher. So in terms of the uncertainty of a discipline. So within this framework is quite broad. We only pick some examples today just to illustrate the possibilities of rethinking about using uncertainties as a part of our looking at our conventional or current methodologies, and to see whether this uncertainty concept can bring us new perspectives to look at those issues slightly differently, or sometimes even fundamentally differently. So that was the intention for this, the multi-level visual analytics studies at different levels. How do we recognize those patterns? How do we follow the signs provided by these kind of signals? And then also, I will give you some examples about different types of uncertainties or different types of scientific knowledge. They have different types of uncertainties over years. So you can imagine the uncertainty could be increasing, could be decreasing, could be increasing and decrease. So I'll show you some of those examples just to highlight. There are lots of things actually going on. If we do not pay attention to the uncertainties, underlying uncertainties, lots of issues, interesting issues we may miss, and lots of important ones the question may never get asked. So eventually, or at the last one is I make some observations, and based on my own experience, I give you some recommendations or which way we should look at or pay more attention going forward from there. So this is a basic outline. So I will just getting a little bit deeper from here, but I hope this outline give you a general idea which way we're going. So if you feel you get lost in the middle of this process, feel free to raise your hand and give me a reminder or anything. Yeah. Okay, so first about theories. There are lots of theories from different disciplines about how scientific fields are supposed to develop, what are the motivations for researchers, and also how does the evolving intellectual base or any, so totally speaking, there's so many theories. And then you can see my message here is just like the elephant. Lots of people look at this from their own perspective. So it's very beneficial if we consider quite a few of them to look at how they address the same issue from different points or different perspectives. So in this today, I'm going to just take a one to begin with, and then we can use other theories, cross-reference with other theories to see what are the things predicted by this particular theory. What will they look like when we visualize them, when we see those patterns? How do we interpret according to this one, or if any other evidence from other theories could support or against this kind of observation. So this particular one, I like it very much, is proposed by Schneider. And this is so-called the four-stage theory. I call it four-stage theory because it's, first of all, it's very intuitive. It focuses on problem-solving process and applying that process to the evolution of a scientific field or a research field to be a little bit broader. So I'll give you a summary here. So basically, we're going to look at this, a new field is started with a question. So stage one, there are going to be four stages altogether. So stage one is the process, the point people identify a problem. People agree, realize this is indeed a problem that worthwhile for people to pursue. And that will be stage one, is you can call it conceptualization. It's build the reason, the motivation. This is something we have to do. And we have to do it together. And maybe take years, then take decades, and so on. So after that, the second stage is really logical. Once you have that problem, you better sharpen your tools and you provide your new equipment or specifically dedicated instruments to solve that problem. Because suppose this is a new problem, the tools will not be readily available to do what you like to do. So the stage two is typically the tool development or instruments. You want to, for example, you want to have a telescope, develop a telescope to serve your purpose of looking at further away from the Earth, some in the deep universe and that kind of thing. So the next stage is once you have the tool, you're supposed to solve the original problem. Now then you can apply that tool to the question you originally asked. Is there any solution or anything that tool, does it work? You apply to that. So in a nice or lucky scenario, everything resolved as planned. So you move on to number four, the stage four. Everything is should be documented as a codified knowledge, written in textbooks and so on. So that will be the natural end of this field. There's no motivation going further and so on. That's the one scenario. The other one, you can branch off from stage 3. You can go, once you have the tool to apply to the original question, then you can apply this to new questions. By applying one tool to a new question, then you can trigger some of the new questions and that have never thought about it by anybody before. So you can see that may be a good chance to repeat the same procedure, but this is the development of a new field. So this is a very flexible model to look at it in this way. And also any individual stage, for example, number 2, you can see itself could branch out a new field, just focus on tool development, and tool development by itself could be become a subfield, and then so things go on like this. So this is what I like about this theory, because it gives us some framework to look at what's happening based on our in partially data-driven, partially is a theory-driven process. So we can look at what is the stage of this particular research field, and what are the next stage we can expect? What are the problems here, and what's the way to go forward? So this gives us a very higher level, strategic level of thinking. So this will be helpful for researchers at any stage, younger ones, more experienced ones, or even for people thinking about switch to another stage, another field from another stage, and so on. So this is, I just plug in here, is very inspiring for us. So some of the visual illustration, as you can hear, we can visualize the fields, and the fields can be divided in different streams, different topics, and subtopics. But interesting observation here, you can see the length or the duration of each one could be quite different from others. So there's some switches from short one to new ones. There are some stream simply terminated because we mentioned before, run out of the problems they need to solve and they move on. So all those things could happen. But here, this is a connection here from a theory, what theory says, and what can visually see what we can see in the data. This is scientific literature data, so we can have a better understanding at the microscopic level, the patterns, the trends. So this is beyond individual nodes. So this will give us a good picture what the science is going in this sense, in this particular sense. So the next part is going to deeper. We're going to dig deeper in the structural properties. So before we move on that, are there any questions at this point? Okay, so I'll move on and then we can ask the question again.
Here's one question from Ariane. Ariane, if you want to pose your question directly, you can unmute yourself and ask your question.
Hello, thank you for making room to ask a question. My question is quite fundamental, having read some different authors in philosophy of science. I was wondering how you define science in terms of delimiting it from other forms of knowledge.
So in this context today, I would define science very broad as the research. So research including natural science and physics, like physics and astronomy, and also include social sciences. So anything that the research activities are involved will be called scientific activities. So scientific knowledge will be the outcome of those activities. So okay, this is my very broad.
Thank you. So structured, it just requires structured inquiry. Yes.
Not structured inquiry. What do you mean by structured inquiry?
For methodological inquiry, so research, yes.
Research, yeah, any methodologies of research to go should be included here. So very broad, and anything it is, as you can see here, the frame is problem solving.
Yes.
If you have a problem, if you can frame it as a problem, that will qualify for knowledge.
Okay, thank you.
Correct. Okay, thank you very much. So, okay, let's move to second part. So structural properties. So we're looking at the structural properties and to see if we can identify some of the properties are more important, more significant in some ways than others. So to begin with, this is an very earlier work by, this is a project from NSF in 1960s. They're analyzing the inventions. But here I want to borrow their work and their report from the experts. You see those parallel lines. They emphasize there are lots of research before the actual invention. This is a tape recorder. So the point here is there's almost nothing cross-reference or communication between them until sort of the last minute. So this is a very important point I want to make here. So it will be a good thing that we can know what is the right time to make the connection. So this is also part of the lots of theories about creativity. Is as if you are searching for what you know, but what about those things you don't know? How would you search those things you don't know? So we're going to look at the signs or the patterns that can suggest, make some suggestions or early signs. That's so we can pay more attention as soon as possible when those signs appear. So this is the frame for what kind of structural properties we'll be looking for. So the one we're going to look at in particular is called structural hole theory. This is actually a theory developed for social networks, not necessarily for the concept net or the networks of the citations or the co-citation we're going to use. But after some study, after some homework, we found this is really applicable. So the basic idea here is when you look at the structure of a network, the position or the value of those positions varies, depends on the connectivity. So this may be a very simple thing to detect. So on the other hand, this is very fundamental. It suggests there are some places or some properties we should pay more attention. So things like here, highlighted in the red, the bridge. So this one connecting two groups. So we extend the connection from social network to the concept networks. So in the concept networks, for example, when we look at how two papers are cited together or how one paper is citing another, we're looking for this kind of bridges or the lack of this kind of bridges. So if we don't have this bridge, and then that means the idea is not there yet. And if we have this kind of bridge, it may be a source of creativity or some other things that can come with it. So basically, this is another theoretical piece that I would like to mention here, and quite a few things we have been working on will build actually built on this understanding or this principle. So some of the earlier works, I did analysis on the literature for terrorist attacks and terrorism, the research. So as you see, based on the structural holes or the gaps or the bridges between them, that actually illustrated here in this example, it highlights some of the most important or actually most valuable links or nodes or areas. So this is a very effective filtering mechanism. We can highlight this, and once we understand what is the meaning of this bridge, we can understand how the different components of the whole system are connected together, which means that will be a much better understanding of the higher quality than if you look at individual nodes without looking at their context. So this is the way we use this structural whole theory. But then we're going to move on here further, still inspired by this theory. I'm going to show you some of the other methods we developed to address this issue. So here's another example from another domain. This is literature-based discovery, and this is domain. Now you can see the colors showing, actually you can see visually that it looks like two communities, and they're reaching their hands to shake hands with each other. So this is one example. The type of creativity, the movement of creativity happened in the literature. You can look at this way. You're looking at these are the bridges was missing, and they are building this, creating new one, and two fields on both sides are connected. So this is a common pattern. So I just illustrated one of them here, to give you some idea how could you apply this structural whole theory in the analysis of a research field's literature landscape. So all these things are moving, so you can see where the keys are. So now, if you look at this, the papers at in the middle of the connection here, like the bridges, they're also very highly influential. So that gives us an idea. What is the value of a research, and what is the meaning of a research excellence? So what those kind of papers position in these special places, what's their contributions, why they are getting highly cited here. The red circles indicate a citation burst. There's suddenly lots of citations, people pay attention to these papers. So people know what the valuable things are, where they are. So they follow up this. So the question is, before this happened, how do you know which area you should pay more attention and which area you should plan your study or research? And so that's an issue, I guess, for all the researchers to be thinking about it. So those are the structural part. So the kind of the takeaway message is structural whole theory, the bridges, brokerage, those are kind of concepts. You can apply this to the analysis of the field, of the literature of the field. So the next one coming up is going further. How do we build on this structural whole theory to develop a further analysis, a little bit predictive analysis here? This also based on this structural variation. So before I go deeper here, any questions? Any questions about the first part, second part? All right, so I'm just going to ask once and move on.
Yes, please.
Okay, so this part is based on this concept called structural variation. Now, the actual framework is quite intuitive. So we think about all the knowledge here in the center circle here is collective intelligence. That is everything we know collectively. Collectively over time, collectively across different disciplines or anything. So you can ask anybody, any experts, whatever the knowledge, we put it together, that's a collective intelligence. So these things are changing. You see a lot of signals from different sources. We can get all this from papers, and you can have other sources like clinical trials, you can have patents. These are all the sources that everyone actively working on some research, on their research, could be affected. So this is the whole point. They get all the signals from around themselves, and sometimes it will trigger, those information will trigger a change. Sometimes it won't trigger any change. Sometimes the change is very revolutionary, Some other times it will be gradual or evolutional. So the analysis here is try to build on the structural whole theory to move a little bit further to identify as soon as possible when any sign appears that this area could be a good place to appear a new bridge. And so we measure different kinds of things to highlight that. So this is the theory about that. How do we go in that direction? So the illustration here is just to show you before on the left. We have a system, we have a perfect system. Everything we know makes sense, cohesive and consistent, and so on. So we consider this as a complex adaptive system. That means that outside the information here keep poking at the system. Sometimes they trigger big change. Some other times it didn't change the system at all. So the value, that's another principle we think. The value of information is really can be measured by how much the kind of systematic change or global change they can introduce to a system. So as you can see here, one of those messages suddenly change the whole thinking. Thinking is different, or that will be something underlying Kuhn's theory, scientific revolutions. So the old system is no longer applicable. The new system have a new life, and so this is the highest level of those models. So at the operational level, we think of this, we can do this based on networks analysis. We're looking at the networks, but also we're looking at the incoming information to add it to this network. Each time a publication or paper is published, and they have lots of references, but the way they cite the references may add or may alter the network structure in different ways. So for example, here we look at some of the network as a whole. We can divide them into components, we can divide them into different parts. Some of those links, they happen within specific components. And so you can imagine at the system level, the changes they could trigger is relatively low than those links between different components. So those are the basic idea intuitively. That will be how we anticipate this link happened within the same island, or is link happened build a bridge across two different continents. So those are the two different kinds of links. The one that build the bridge, especially build a very novel bridge, nobody has ever built that bridge before. That will be something we consider as has a high transformative potential. That means you can build a bridge wherever you like. But then the matter is, how many people will follow, how the cars or traffic will follow to use that bridge to increase the value, to recognize the value of that bridge. So this is two-part process. The first part, you need to build a bridge. The second part, if nobody used the bridge, nobody recognized the bridge, the value of the bridge is nothing. So that's why this two-part is really important thinking. So you have the signal to identify the first part, but then we'll have other signals, for example, citations, the burst of citation to recognize the second part. So until the second part is completed, we don't know. It's not really yet to evaluate what's the real value of that bridge. So we don't know yet. So it depends on the community. So that sounds very like a social construction. You have to see how many others recognize the value of that particularly newly built bridge. So here's an example of when we apply this. So this is before, and this is after. So you can see this is after. Lots of people are actually supporting this bridge. So they use it, they reinforce it, they have very good time. And here you see lots of stars on this newly emerged island. That's what people actually do. So this is another interesting picture here. This is newly emerged island from the ocean, but you can see that the people here, what they have in common is they all build the same bridge that was never existed before. So this is, as you can see, this is a level of the patterns or the changes we're looking at, not only at the individual papers contributions, but instead we're looking at the communities, at least the sub-communities. How do they follow what is new? And so this will lead to the next few topics, the dynamics, what triggers this kind of new movement, and what are the factors we should consider, how long this movement should be moving around, or how long they will stay at one particular area. So the other inspiration we have is really nice, or from these Chaomei's list of questions. So this is, again, is about, you can see this as a problem solving process, or actually originally was provided as a criteria. How do you evaluate the quality of research proposal? I highlighted the first one. I highlighted. I only highlight the second one. The first one is what you're trying to do. Try to explain it. So that's the focus. So in a way, that's similar to Schneider's stage one, the conceptualization stage. The second question is, once you identify that problem, you want to know what is the state of the art. So state of the art is a really, really hard thing to pin down. So that's why I highlight this one here. So for the probably most of part of what we're talking about today is the effort to try to solve this problem. Okay, so the question is, how is it done today? And so that can be rephrased it as what is the state of the art today? How much do we know about it? And then I will go even further to introduce the concept of uncertainty. How certain are we about what do we know, what we don't know? And so from there, researchers spend most of their time to keep track what is the latest, and so try to identify what is the state of the art. But then there are lots of problems from there. Everybody, well, not everybody has the same assessment of the situation as anybody else. So everyone has their own interpretations, have their own scope of their expertise, and have lots of different things. So how do we identify the true or the underlying state of art, if there's such thing like that? So we'll try to get as close as possible. So there's some other relevant works I would like to mention here. One is about the studies when they have the results, the strength of the results is, seem to be swinging and then converging at the same time. Similarly, another study about the consensus formation is how the different ideas or different topics they have been debated. Over time they have been the debates is become consensus, and then that's the similarity between these two studies. So those two studies actually represent the conventional thinking. I will put it that way. So now we're going to look at the other issues, in part to answer some of the questions, and perhaps from a more intuitive perspective. So I'm going to move on to section 4. This is about the dynamics. So we have talked about the structure. Now we're going to look at the dynamics of the attention space. The attention space is where the focus, where the activities, hot areas, hot spots, and so on.
Chaomei, do we have time for a question that came up in the chat?
Yes, of course. Yeah.
Ali, please go ahead with your question.
Thank you for the talk. I was just wondering about one slide you had on paradigm shift and Kuhn's concept. I'm wondering if there is a publication that I can read more to know about that study, please.
I didn't quite follow the question. You said one of these slides. Shall I go back and tell me which one?
You had a slide on paradigm shift and different concepts close to Kuhn's concepts. I'm wondering if there is a link that I can read. It was after the structural whole slide. This one exactly. Sorry, two after this. I'm sorry.
What?
No, there is two more after. No, after, not before.
Oh, after.
Yes, exactly. That one with the yellow that had the paradigm shift, and I'm wondering how did that. There is one before this.
You mentioned Kuhn's theory. Is that what? Did I get your question correctly?
Yes, there is one slide before this that has a yellow visualization, and there is a focal point that apparently the paradigm shifts, and I'm wondering if there's a source that I can read more on that.
One more slide here. This one.
Exactly.
Oh,
The
okay.
turning point, and then there the paradigm shift happens. So I'm wondering about that.
Yeah, this one published in my 2006 thesis paper. You can search for it, or I can give you a reference at the end of the talk. Maybe I'll send some references to Jennifer, and it'll be good to share the references.
Yes, I would be happy to share everything after the talk. And there's another question from Jody. Please go ahead.
Or similarly, this slide here on structural variation analysis, I think this is a really interesting framing. And if you have a reading to suggest later, that would be helpful as well.
Okay, I'll give Jennifer another reference. Thank you.
Okay. Is there another question at this point? Okay, I think we can go ahead.
Okay, let me write down the references I need. Okay, so this is a kind of visualization of the citation burst. The red segment for each line is the period or the time when that particular paper is, the citation to that particular paper increased dramatically, so to speak. So if you look at this, what is striking is different papers, they have their more or less the same sort of period of time, they get attention, and then the attention moves on to other ones, keep moving as we go from over 1986 to then 2018. So this is something I would like to explore a little bit. This is about the shift of the focus of research. So as you can see, many different people, they have inspired by one paper at one particular time. If the time moves on, and then their interest most likely will change, will switch to another reference or another sources. So what we're going to look here, what can we learn from such kind of the dynamics of movement? So there's another way to look at this. You see this network of citations. They're not staying in one place. Instead, they keep extending from the existing network and adding new ones and going forward. So this is a common pattern found in many the literature, many research fields. So this is very typical, and it could be understandable. You don't stay to study the same issue for a very long time. And also that leads to some other sociological theories about scientific research or scientific change. So in part, people pursue not only the knowledge, but also pursue the novelty of their research. So they're motivated by finding something new. So to find something new, more likely is to go somewhere that nobody else has been there. And that is probably very logical, natural thinking. So that's something we're going to look for and to see whether that's the case. So here's another example from this visualization based on timeline. So we can see the researchers, lots of concurrent research fields, and some of them have a communications between others. Some of them they don't have so much, but again, the lifetime, each one of them is the interesting part. How soon, how long people may stay in one cluster, how soon they will leave to study another one or some other parts of their research path. So this is a sort of more recent example about, this is actually about coronavirus, but you can see the movement like this. So here's an overview of the network. You see all those the lines, if I can annotate. Will I not annotate? Let me see. So I'm going to use this annotate right here. So you see the links here highlighted. So those are the links at this particular year, 1995. So all the others, you can consider them as the background. So the research here, you see the starting from here and all the way back to 1995 was like that. So you can going further from here to see what is, maybe you can try to make prediction. What will be the next area, the focus next year, 1996. So 1996, you see 1995, I got 1997, it come to this area. And 1998, 1999, 2000, keep going, 2001, and so on. So that's the dynamics of this type of thinking. So you have the baseline or the network, but also more important or more interestingly, you can look at how different topics at particular year, particular time, people have paid their attention, lots of attention there. So that's in part why it's called the attention space and the dynamics attention space. Okay, another time for questions before we go on for the next topic, for the uncertainties.
Anyone a question? Maybe I can ask a question because you were just talking about how to make predictions about what research areas will be the next ones that are of interest of researchers. And I wonder, or did you also study other influencing factors that have an impact on research trends? I mean, it's not only driven by publications and by citations, there's also funding, there are also other maybe political reasons.
Right.
So do you have an idea about it?
Yeah, you see the model, we have lots of different signals from different places. Funding is certainly a very major source of impact. Actually, some of the fundings make a great contribution to visual analytics, for example. And so certainly people have to look at all these factors. But for once you consider this, or at the principal level, everything at the lower level should be similar. So if you know how to handle the papers as a source of signal, you will be able to expand it to handle other signals, clinical trial, or sometimes even you have this daily news. One particular drug is found and not very safe, have a lawsuit, and they have to replace it. Those things could trigger lots of other questions about patents, about what's next steps for your research.
Right. Thank you. There's another question from Ravi Kumar. Please go ahead. It's not working. We cannot hear you.
Or maybe typing the chat window.
Maybe.
Yeah, maybe we should move on, and once you can get in the chat window, or maybe at the end of this, we can visit.
I will have a look at the chat again. Maybe he can propose his question into the chat, and I will read it.
Yeah, sure. Okay. Okay, so let's move to. Okay, so we're going to look at next topic. So this is about uncertainties now. So let's take a look at a typical research paper. And so we can see some of the things will stand out. First of all, I highlight here is this kind of a sentence, or this kind of sentences are really common. So usually this, yeah, the effects of treatment on this dimension of the illness has been unclear. So this is the signal we're going to look at as a part of the efforts to get what is the state of the art. So the state of art means what is the best thing we know.
Okay, he's here now.
You have a question?
Ravi Kumar, are you here?
Yeah, can you hear me?
Yes.
Yeah, now we can hear you.
Yeah. So my question is that during the evolution of subject, and we are identifying the evolution of subject through the citation network, whether any possibility is there to identify the evolution of the subject which is having the effect from the internal factor and the external factor?
That could be many factors. Yeah, both internal and external. So this is indeed a really complex phenomenon we're dealing with here. So the people, actually, the beliefs, so we're going to talk about beliefs shortly, very soon, on this uncertainty. So the people's beliefs can change, and sometimes can suddenly change a lot, and sometimes will never change, even give the same signal. So that's a combination of what the people know themselves, what their own experience, and also what's external triggers, and so lots of possibilities. So in part, that's why I call it complex adaptive system. It's no straightforward way to predict. Once you tell this story to someone, they will how will they react? So this is the same issue, same level of complexity. Does that answer your question? Probably not. Okay, so I suggest we move on, and we can. I'm sure we have some time to discuss in more detail later.
Yes.
Okay. Right. So this type of sentence is really common. So if we classify them or categorize them, we can see there are several different types of ways in natural language to make our arguments. This is common, also probably a good introduction for people to write scientific paper. And you can see the colors. I use color coding 3 categories. One is called the lack of consensus. So the purpose of this line is to indicate there's a lack of consensus. And there's other color like hedging here. Each of these is believed to, so this type of words have their roles. We're going to expand it here on this concept later. But the point here is whenever whatever the types of research papers you look at, all these types of the roles they have are in common. So regardless what is the specific topic or the subject, you can have this type of things that is invariant. It's always found in different research papers. So those are the basis or the signals we're going to gather and to measure what is the uncertainty of scientific knowledge. We're going to go further on that to introduce other concepts we can build on so that we can do the measurement more effective. So as you see, this is if I pick another paper, similar thing happens. Some sentences about lack of consensus, some sentences are full of hedging, some others about transition. And so you can look at here and see some of the, if we analyze the full text, we can see different sections may have a different frequencies of this type of use, different categories. So to summarize all this into some sort of framework, we recognize this this kind of a template could be useful. So for example, we call the we use different names, either called a predication or proposition or claim. Basically is a very simple or the simplest statement about a belief, about opinion, but describe all the other minor details or nuances at this point. So straightforward statement. So this is what we call it. Predication or proposition or claim. I use it all these to refer to the same thing. So the example here is HIV causes AIDS. It's a statement. The truth or the false or the truthfulness or the uncertainty of this is a different issue. So that is an important distinction here. When we deal with these claims, we have to deal with what is the context when people express the claim, when people make this statement. What else did they say here? What are the other signals they have? What are the evidence they produce? So if we look at these examples of this template, different sentences. For example, number 2, there's growing evidence. Growing evidence. That means we're more certain now than we are before. So the third one is the question whether we can substitute that claim there. The question whether HIV causes AIDS has been controversial. So that's one statement. So someone says that's controversial. That means someone's assessment of the state of art may be different from yours, from experts, from other people. But at least that's what we can find in the literature. So this is sort of uncertainty. Give us a lot of information. Actually, we can go from there. So other types, for example, here, contradictory findings are reported. So there's some contradictions. So when we have this knowledge, if they are not consistent, if they're inconsistent, if they're contradictory, if they're conflicting, so we need to resolve it. Before that, there should be no consensus. We need to resolve those conflicts. So here, I just highlight this is the template we're going to computationally streamline so we can analyze at 2 levels. One is the claim level, the other one is the surrounding signals or surrounding noises about how certain the statements are made in a particular context. So I have this very simplified chart. First of all, uncertainties equal meta-knowledge. So if you only know those statements, HIV causes AIDS, without knowing the truth or not, or to what extent we have evidence to support that, we don't have the full scope of the knowledge. So the reason we said here, this uncertainty is actually the meta-knowledge is something about the knowledge. It's how much you actually know accurately or precisely know where's the boundary of this. Not too much, not too little. We know growing evidence, we know something unclear or something unknown. We need to know this status, the right place at the right moment. So that's in other words, I mentioned here, that's the source of expertise, and that is the expertise. Not only you know the statements, you also know the truthness of those statements. At one moment, when other people have different opinions or make different arguments, you can estimate, you can assess, and update your beliefs accordingly. So this is the framework of that. So you can see this is what I call it epistemic status. Epistemic means knowledge, purely based on knowledge. And the other two categories we're going to mention later on is called the hedging and transition. So here are some examples. From the sentences, these sentences they mentioned. First one, the mechanism is unknown. So how things work is unknown. So similarly, something is suspected, something is unclear, unusual, controversial. There's no consensus. All these things, as you can see, indicate this is a motivation for a research field to move on. So this is a driving force behind it. Without this, if everything's clear, everything's no consensus established, probably there's no point to go further on that topic. Everybody knows, settle. So this is a different way to look at this. Instead of looking at the unknown or uncertain as something we don't want, actually it's a part of it. It's an integral part of it to have to deal with. And also that tell us something about the state of where the things are, where the things we should think about. Maybe we should probably leave this field if everything is almost certain, everything almost reaching a consensus. So this is examples from PubMed. You can see lots of these sort of examples. So in this table, the example here is over time, this kind of uncertainty will change or can change, mostly will change because people spend time on it, and previously unknown now becomes something better. We know something. At least we have some suspects, and now eventually we have the last one, as you can see here, suspect some reasons is much better than how we got begin with. Is the whole thing is categorically unknown, but now we know something, but more precisely the level we still don't know. So this is again emphasize the role of uncertainties in understand scientific knowledge, how it's created. It's very critical, fundamental. So that's actually, you can think about, this is part of the knowledge a researcher should have. It's not really about the physics. It's also include how do you know how much part of that physics is certain or is uncertain? To what extent is uncertain? So this is the expertise I mentioned here. Expertise is the knowledge of uncertainty. So experts will know about the state of the art to that level. So this is get on to the operational level. How do we actually do this? So if you can see, this is a one sentence, very complex sentence from PubMed about HIV causes AIDS. So that statement is really short, but the context is wrapped in a very complex context, lots of them. So for all these concepts, we want to focus on a few types of uncertainties. The most important one, like a significant one, is the epistemic, because it's about the knowledge. If you have a contradictory or information, you have inconsistent information about your knowledge, and that's something we can't really settle with. We have to get that resolved. So those are the words here selected in the paper. Here, the reference there, you can look at the details. So basically, we get lots of synonyms or got a semantically equivalent words when people have these kind of expressions. Something is unknown, something is uncertain, some incomplete, inconsistent, unexpected, different levels of this expression when they say about the statement. So we put all this together, categorize them, and so we can use them later. So these are the examples about the epistemic. You will see later on, I use the letter E to stand for this type of uncertainty. H is hedging. Most of the time, when people use natural language, they use a hedging to soften their statement, or actually, as you can see, they provide a buffer to defend themselves later on if people attack them. They could use hedging. So I didn't say that absolutely. I said implies, so things like that. The next type is transition. So when you make an argument, you suddenly switch your decision. That's a kind of a transition. And that indicates another kind of uncertainty because of two scenarios, at least two scenarios exist when people doing this kind of thing. One thing on the other hand, on one hand, however, so this type of signals indicate something people said there should have indicate something that is different interpretation or different theory, different perspectives. So we put all these together, we can look at which discipline is highly uncertain based on all these measures. So the measures are actually included in the subtitle on top. These few words: unknown, unclear, controversial, no consensus, conflicting. So which fields actually, when people publish, they wrote a lot about this kind of thing. So you can see the list here. So now we're going to switch to even more detailed level about how do we calculate uncertainties. Any quick question before we move on?
Justin had a quick question, but I think he has connected.
Can you hear me?
Yes.
Chaomei, thank you very much. I'm of course, when you're talking about uncertainty and hedging and all these different ways of expressing what we don't know, the current situation is so loaded politically, and there are so many researchers working competitively but also collaboratively to find solutions to this coronavirus and treatments and a vaccine. Do you have evidence this has changed the tolerance for uncertainty, or there's more pressure to use less of those kinds of qualificatory words?
I think at least I heard this word uncertainty a lot more recently. So I think that's a good thing to raise people's awareness. Uncertainty is an important part. It's been there all the time. It just highlighted it now when we have to make decisions with uncertainties. What can we do? So those are really a decision-making issue. And if you think of that way, that happens all the time. It just that when the decision becomes urgent, you have to make that urgently, and that really highlight uncertainty. That's not a way to say you make decision with uncertainty, you're responsible to whatever happens next. You have to think through what are the possible scenarios, and so to go from there. I think that will be a good way to handle the situation. And yeah, I think that from people with such experience, they should be more considerate about the uncertainties and how they make their decisions. So I think that's generally a much bigger question than the scope I'm focused on today. But that's a good question. Yeah.
Thank you.
Right. So we're going to move on to the semantic predications and how we use that to measure the uncertainty of the sentence and of the article and the collection of articles. So this is from PubMed. So basically we can look at, PubMed is a biomedical focus. So we know the This is the predicate, so we can look at the treats. Something treats some diseases, or something affects diseases, or something causes diseases, something inhibits. So this type of predicates are really common. So mostly you can, this makes sense, you can deal with this type of statements. So the beliefs are about what works on what diseases, disorders, and what doesn't work. So we're going to use this as the base. So the continuing further example is about HIV causes AIDS. So we can see about this particular claim, regardless what you think is uncertain or certain, you can see the popularity or the common focus in particular time of year, on a particular year of the history is different. So that's also what we see earlier, the dynamics of the shift of the attention space. And so people sometimes looking at this, but once you believe this already solved the side of the topic, they will move on to more other topic, can bring their more novelty and originality, or other type of things motivated by different ways. So some quick examples about how a statement or a claim can be surrounded by many words that can indicate some level of uncertainty or some types of uncertainty. And this is surrounding context is what we use to measure the uncertainty of that central, the focus statement or the focused claims. So also we can see here, this one example is called the hedging or the suggest. So the word used here is suggest. It leaves room for further indication. It's not absolute. It's some level of uncertainty. So this type of uncertainty is not as significant as the epistemic. I'm going to show later on. So that will trigger the updates of our knowledge, but this type suggests maybe we're there, we're almost there. So vaguely is a little bit blurry, but things are in the right direction. So that sort of answer. So this one is quite certain, is now known to be caused. So now known is a consensus. Now this indicator consensus established. Nobody really going to argue more about this one. So this is the sense, or you can call it a sentiment, that we can detect from here. So this is another example from the other side, from the negation, is HIV is not a case of AIDS. That's actually a title. And then you can see this one, you can see the length of the statement and the length of the surrounding context of the statement actually tell us something. So if you wrap this claim without almost with nothing, or without the long sentence, and you can see that's another sign of pretty certain. So this one is kind of read like HIV is not a cause of AIDS, period. And then you can see another layer of complexity. Another layer of complexity when other people refer to this statement, their position perhaps be neutral, but we don't know. So here's one example. So he stated, HIV is not a cause of AIDS. He stated, not me, he stated. So it's getting weaker and weaker, this statement. In other words, it's getting more and more uncertain. So next, I'm going to move on to the visual analytics processes. And this is a multi-level, and that refers to the article level, sentence level, and the aggregation of articles. So maybe we're approaching to the end. We'll leave all the questions to the end of this. So as you can see here, the example just show we can analyze the claims in a similar way as we analyze articles, references. So these are the networks of claims or networks of semantic predications. So at the article level, you can see here, given a network, we can divide a network into different parts, different regions, and those regions, we can have a label. These are called the clusters. And individual nodes can be highlighted based on what they have, special information, for example, all the red stars here because they received the funding from NIH. So this is a more global view about the infectious diseases. So this is actually not all about infectious diseases. It's the not 900, not 900, 95 percentile. So these are all the influential ones based on the citation behavior. So let's take a look here, some examples. And you can see some concentrations. Lots of topics about HIV, they tend to get together. So this is article level. Remember, this is article level. And similarly, there's some similarities between them. So that's why they are grouped together. So this, for example, multi-drug resistant and some other things I can't even pronounce, but they all group together. So these are the ways to see this network actually grouping the common topics together. So we're going to see how we can apply the similar methodology to the semantic predications and how can we go there and calculate their uncertainty. So this is, as you can see here on the left column, they're all claims. They're all like the HIV causes AIDS. And then you can see they are mentioned. But what we don't know at this level is how much they are in any uncertainties associated with them when they mention this kind of statement. So again, the shift of attention space, you can also recognize it here. So here's an application of the structural variation analysis. Remember, we have following the principle that structural holes or the bridges, brokerage links are important. So here in this kind of, at this level, so we know we're looking for is the statements or claims that have never been mentioned together. So this is similar to HIV causes AIDS has never been mentioned with another one. Now here we can identify the lines in red. These are the ones that newly added. Let me annotate. So these lines added here, they are new. So you can see here before they adding these lines, there's no links there. But they added this line, but these lines added, they qualify again based on the computational measures. They qualify as a something we need to pay attention. As this is the step one, they build a bridge here. But whether the bridge become popular or not is a different matter. We have to wait a bit more to see that. So you can see there's a little bit more closer here. All the red lines are potentially novel. So potentially novel at the level of system level is not locally level, is globally novel. So that's the point here. Let's see more closely. And some of the statements or some of the predications here and the antibiotics treat patients, that's very generic, but also the novel links between them connected to other more specific predications. But at least you can walk through, you can see which year is added in particular. But this one, at this point, we have not introduced the uncertainty measures yet. But it will be useful or valuable to know which ones are really focus or trouble or debates controversial between the researchers. So here's just one example. We can highlight all the topics, all the predications are associated with autism, or at least they're mentioned within the paper about autism. Okay, so move on to 8. We have 9, so this is almost the end of it. So the rise and fall of uncertainties. We can measure uncertainties of a sentence. It's not really a sentence. Of a predication, I mean a statement, we consider that as a belief. So now you can see here, for example, the bigger one. The annotation again. So we can see here the red line in the middle is the moving average of the uncertainties involved whenever this vaccine treats child is mentioned. But actually, when you see the actual sentence is more specific than this. It's loosely defined or combined lots of sentences closely represent something about vaccination, treat child certain specific diseases. But the lighter area, they are the moving standard deviation, corresponding moving standard deviation of that. So we can see the uncertainty of this particular statement is changing over time. So the more interesting part when you look at this, there are different types of ways to change. So some begin with very low variation, and some begin with very high, but then quiet afterwards. And some uncertainties reduced over time, and some uncertainties increased over time, and some uncertainties look like they change a lot. So the next thing to do with this kind of scenarios are categorize them, group them, so we can recognize the type. For example, as I mentioned, if we have some patterns like this, so this indicates a pattern that the uncertainty is actually reducing over time. So that's another way to show this is the consensus is formation. So that's another way to read it. Uncertainty is the sort of the opposite of consensus. If the uncertainty is dropping, and the consensus will have a better chance with reaching the consensus. So we get, this is basically how do we get there from a network of the predications. And now the red circles, they are the ones with uncertainties. So with the lots of them, this is only preliminary work. The machine is still running. I have to wait for further to get more updated results. But this is the beginning. We see some of the uncertainties about the specific topics. So here's a more close example. We can see if we measure the uncertainties, we can select the sentences or the claims about vaccine causes autism. So this particular one, you can see different sentences, and this claim itself is buried or is embedded in all these contexts. So by calculating all the different signals from all these contexts, we can reach a measure to what extent this particular one over time, what is uncertainty in terms of epistemic uncertainty or hedging or transition sort of uncertainty. How does that change over time? So once we have that from the network, we can pop up this kind of a window so you can see first. Let me get up again, this annotate. So first of all, you can see a window here. It shows you when all the sentences mention this topic. And these bars, the longer the bars, the red bars, the longer the bars, the uncertainty of that particular sentence is detected. So that go back to this graph, you know which time or which year this is the topic that was greatly debated or highly focused. Then that actually help us to narrow down, okay, in 1991, this is a very long bar here, and we can narrow down the sentence here. Oh, the reason why the vaccine fails in some children are unknown. So that was the reason. That's the reason this particular part has the uncertainty flagged so high. And then we can trace from here, and this is the full paper or the abstract of paper. It says this is the context you want to read. This is the second sentence in the abstract, the reason why this one is unknown. So this is an example of visual analytics go down to many levels, from article level, sentence level, back to article level, and go high. Depends on the topics. So here's a little bit further example about this vaccines causes autism. That's one claim. So we know this is the highly cited, retracted article. This is very famous. There's a lot of studies about that. So I think I'll go through this very quickly, and then we have some time if we can go through this. Yeah, so this is the data is collected based on how other papers cite this retracted paper. So you regard this paper already retracted, what people say when they cite this retracted paper. So we can look at them, we can visualize them as a network at the article level, all the papers citing this particular Whitfield paper retracted, and what are the topics they're talking about. So this is a very similar way we have before. We can also identify this in the direct citation network, the topics, and so on. But more interestingly, the lower left, these are the red circles. They are the uncertainty, epistemic uncertainty levels. So those are the, I think those are the papers actually have highly uncertain statements in it. And actually, we know that one paper, actually, this is based on the abstracts. All the uncertainties identified from the abstract level aggregated to the article level. So we know that a particular article has the uncertainty scores. Here's just one example, interesting example in a sense that you see 1999, lots of highlights here in a sentence, unknown, unknown, unknown. Except the last one is a positive, but it didn't say anything about the unknown or known. 2009, so that's 10 years later. 10 years later, uncertainty is still very high. The mechanism of this is still unknown. So let's look further. 2016, still unknown, concern. So after so many years, you see the expression of the state of the art. But this particular statement doesn't change much. So that actually raises a question. If you want to choose this, what happened? Why is this fact that so many people recognize the unknown uncertainty for so long, but the state of art doesn't seem to address this issue after so many years? So this is the type of things where we found very interesting in this kind of work is that indicates uncertainty. At least from 1999, is already known this is unknown. But now if you check the latest one, 2016, and we don't see, or actually the author, maybe the author, this particular author, is unknown to the author, but the fact maybe is known. But that thing is still not in the literature that we study. So this is type of the questions we will put it on head. Maybe unsolved problems over the last 20 years. So this one shows the aggregation of uncertainties can be aggregated from sentence level, predication level to this article level. Article level on the top. We can also aggregate it to the clusters of articles, the showing in the lower thing. So we can measure this in different ways. So this is the last part. Very briefly to summarize what we have observed and make some recommendations. So the basically, I will keep it short. The uncertainty is really important and integral part of it. So all the time, people try either to use uncertainty to motivate research or use uncertainty as a measure how far they they are from the consensus. So that's again is a kind of a motivation. If we look at this, introduce uncertainty as a factor or as a concept, now we can revisit lots of the existing studies or the methodology they have been used. This time we add in the uncertainties and to see whether the uncertainty provides some alternative interpretations of those triggers when things happen. Is uncertainty level changed or not? So if uncertainty level doesn't change, you can use that as a way to measure the research excellence. If the uncertainty doesn't change, what else changed? So those are kind of the ways to pursue the research even further from here. This is a very brief summary about the role of uncertainty, about creativity, everything, how they put together. But the main thing I want to emphasize is just the uncertainty is a meta-knowledge. I want to mention here that uncertainty is a meta-knowledge, is something that you have to know to become really know about the knowledge in your hand or in your mind. So I think this is a point to stop, and then we leave the time for questions.
Thank you very much for your interesting talk. That was great. So, and we're already a little bit over time, but I think we should reserve some minutes for questions. So please go ahead if you have one.
Yeah, we're 6 minutes over time.
No worries about that. I also talk a few minutes and we started a little bit later. Maybe I can get started. And you mentioned, or you were talking about it when you talked about the two communities in scientometrics, and also when you talked about infectious diseases, and that there are some bridge builders in between the different fields and the different research fields, and that they are more cited than other papers. And I was wondering, I mean, citations are somehow an indicator for importance of a paper, but I wonder, are they really the most important papers for the field or for the development of knowledge? Because, I mean, we are all talking about interdisciplinarity and interdisciplinary collaborative work, but actually also, I mean, some of the developments of knowledge are going on within a certain field, and then it's not recognized by others. So these bridge builders seem to have an important function. Maybe you can say a little bit more about it.
Right. The question is about the value of citations or the accuracy of citations is a long topic. It's probably another 3 hours. Yeah. So people cite motivated differently. That's very well known. I think from here, I would suggest we look at the conflicting moments when people have different views. When they cite or not cite is not really that important, but actually what they put there, when they say there's a contradictory findings in the literature, that's saying a lot. That's a valuable assessment of the state of the art from their point of view. The other issue relevant to this is the peer reviews. When they have, when you present a paper to peer reviews, and the reviewers, they evaluate your assessment of the state of the art with reference to their own ones. So they may give you new references you missed, they may suggest the different ways to look at state of art. So I think what's really happening maybe earlier stage before the publication, before the citations, could be at that peer review stage. That actually you can see that as a kind of a negotiating stage. This is what I see. The world is like this, and the reviewer said that's you missed that part. So you revise it and you go further and reach some agreement. So in that sense, of course, that's a citation happens already afterwards, already the agreement established at that peer review interaction stage. So I think that part probably more important than the review. So when the later, what is cited in the later publication. So similarly, proposal reviews and other reviews, those are really determine the course or your assessment of the state of the art.
Okay, thank you. There's another question by Jody Schneider.
So I particularly appreciated what you were talking about with semantic predications and looking at where they are, uncertainty, and so on. So as you think of things to share with us, citations about applications of semantic predications in site space would be really valuable for me as well.
I like to take the opportunity to express my appreciation to those semantic Medline. They have produced these very valuable resources for us to use. So I can make that available, but it's your job to set up your own local database, which could be several gigabytes. That's things I tend to do. I like to share with people.
Okay, thank you. That's great. Are there further questions?
Hello, Stefan here. I just wanted to know maybe if you could discuss what different measures of uncertainty exist in the uncertainty measurement in the literature, if you see what I mean. So how what you presented can be compared to other approaches, and what is the effect of these measurements on, let's say, the conclusions you can draw from there. I don't know exactly how to phrase that because I come from a different field. Maybe you understand roughly what I mean.
I think I can at least answer your question partially, what we did. And so the measurements actually boils down to measure the entropies of the what we call uncertainty cues or uncertainty keywords. So as I mentioned, as a part of the methodology, we first we produce some seed words for those uncertainties, like the unknown, controversial, and the inconsistency, that kind of words, and then feed it to the deep learning, and they fill out all the semantically equivalent words. And then we measure these words against dimensions. Dimension, they have, I think, about 200 million publications. And then we'll see how often or what's the frequency of these particular words appears there. And then we analyze those words appear there and calculate the entropies of those words surrounded the particular semantic predication. So that's the way we calculate this. The good thing about that entropy is allows you to aggregate very naturally and consistently. So aggregate from sentence level to article level and to higher level. So that's what we're doing. And then, so your question is about how different that is from others measure uncertainties. We have looked at the literature, actually look at literature very thoroughly, using our own method of doing the search and mapping and so on. We didn't come up much, we didn't find much studies about how to measure the knowledge, at least in the uncertainties of this type of thing, except the two studies I mentioned earlier on. One is about the consensus in the meta-analysis. The other one was about the consensus formation. That was quite different. They didn't use the natural language level processing. So that's the answer I can give you right now.
All right, thanks a lot. Just maybe just a quick one. So, and when you look at sequences of words, how do you know when to stop? So if you look at a sentence, is that, how do you know how many sentences to look at? What is the non-locality around the words that you measure the uncertainty about?
Oh, as long as that sentence,
even.
Yeah, that's from the semantic predication. As long as the sentence contains or is associated with that semantic predication, we analyze. So that's the scope. So in essence, so we build on the predications. Thank you.
Okay, thanks, Stefan. Any further questions from the audience?
This is Justin again. I have
Sorry. Malik, I think you had the next. I'm not sure.
Thank you very much, sir. Though I'm a very young researcher, so I'm new in the field. So please, can you make any recommendation readings for a young researcher in network analysis? And my second question is that, do you plan to organize any practical workshop on this kind of class?
Can't hear the complete sentence.
Did you hear the first question, sir?
Yeah, you're broken up. I can't really hear the.
Unfortunately, the connection is very bad.
Okay, let me put into writing. I will try and forward it now. I'll forward it. Let me put it into writing.
Okay.
Okay. And there was another question.
maybe one last question. You had a very interesting table with the different disciplines and the amount of uncertainty you found. Is it also true that you find that comparing across disciplines, there are different temporal aspects to these kinds of fundamental but also revolutionary changes, paradigm shifts?
Yeah, there's a understanding that different disciplines, they write differently, they publish differently, they also probably review differently. So that will influence the wordings, and then because our measurements are really based on the wordings they use, and that could be different. So maybe, for example, what we measure really uncertain in psychology, if we can normalize them, they are actually probably more certain than some other fields. So those are things we haven't got a chance to do yet, but there's a lot of possibilities.
Great, thank you.
Okay, the questions came in via the chat, and I think they are good closing words or good questions to close the lecture. Any recommendations, any reading recommendations for aspiring young researchers in network analysis? And the second question is, can you organize any practical workshop on this in future?
Jennifer, can you copy down the chats? I haven't got time to read them yet. I'll make sure I answer them. Yeah.
I will do that. 1 second.
So what's the immediate question I need to answer?
Any reading recommendations for network analysis? Researchers?
Depends who's asking. Are you social sciences or a network of social sciences, social networks, or non-social networks?
I don't know. Maybe you can.
Because the interpretation will be
right.
different.
Exactly.
Human, social, or.
Unfortunately, I can't figure it out here from the chat. And the next question was if you would organize a practical workshop on this in future. Do you have any plans?
I could do it. I could do it on Zoom, maybe.
Perfect. Maybe we can get in touch about it. And if there's anything coming up, any event, I would share that with the mailing list we have here for all the listeners to the lecture series.
Yeah.
Okay, maybe let's close the lecture. It was great again. Thank you so much. And to sum up, unfortunately, we go into the summer break now because in usual times, July and August are quite quiet in Luxembourg and around. So that means that we will come back with the lecture series in September. We have 2 final lectures for this term 2020 in September 22nd and 24th. Cassidy Sugimoto is coming and she will talk about gender disparities in science. And Vincent Lariviere will talk about the impact of social, cognitive, and organizational determinants on scientific knowledge productions. So this is just an outlook on what is coming next. And I thank all of you that you have been here, and hope to see you soon after the summer break. Thank you.